Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatan min lisani yafqahu qawli. Today, I will teach you a very important topic in highway material, in road construction. It's about the mix design and how to blend the material, how to give the proportion of various contribution of the bins in coming up with hot mix asphalt design. This presentation is just another example how Excel solver function can be used to solve your problems, to solve your iteration very easily and effectively. For the sake of this presentation, I have selected the blending requirement for a base course mix design. All my presentation is the specification I followed is from National Highway Authority, Pakistan, and it is for Class A base course material. So let's see how this can be done. Again, using this Microsoft Excel. It's very easy in Microsoft Excel. So what I do is I made this table in which I want, I have 4 bins. A bin of having a size of 25 into 18 mm. The second bin can have a material ranges from 12.5 to 5 mm. The third bin is around 5 mm and around material, while the last bin, the fourth bin, is a material around what we call a dust material, or a material that have size less than 5 mm. Now, what we do, practically what we do is we get, say, a sample from the bins from the plant mix, and we do sieve analysis as per the requirement of our job mix formula. For instance, this is a job mix formula required, in which we required these sieves: 38 mm, 25 mm, 19 mm, 12.5 mm, 9.5 mm, number 4, number 8, 16, and 200. What we have done is we have sieved these materials from the bins that we have received, and I put the percentage passing in each of these yellow boxes. These 2 columns represent the specification set forth by any highway agency for the preparation of the base course mix. So for this base course, the specification limits are being given here. Now, obviously, we are interested in knowing the proportion, how much each proportion is required to mix. So we'll use this solver function as I've explained in my previous video, and I need the proportions so that the total proportion is 100 that is required. So what I have done is simply I've used this data solver function. So I'll go to data. I use this solver function, and I've defined that, my objective is this again, the gradation of the blend that is obtained by multiplying the proportions from each of the proportion. Those of you who already know this blending is that this is the proportion A, it will be multiplied by this thing, plus proportion B multiplied by this bin 2, proportion 3 multiplied by bin 3, and this. So this is the gradation of the blend that is required. Actually, that is what we have got because of having this proportion. And obviously, we require the central limit of the blend So this I have calculated by averaging these two limits, the lower limit and higher limit that is being allowed by our specifications. Obviously, just if you add 75 and 90, the average is 8. So this is the required, this is the optimized. And again, I've used the sum square error method in which I will set this objective to become as minimum as it could be. So that's what I have done, is that, I said this objective is having a minimum value. You can say a value of 0. That will not make any difference. And I'll ask him, ask the software to use this cell 1, 2, 3, and 4. And then I've also said that each of this value, I've said this, add those conditions, that each of these values must be greater than 0 at least. And the total sum of these values should not exceed 100 or maybe around 100. So that's, we have put the condition by using solve function. And then if I press solve, I will get this value. So if I say this maybe say 45, and this maybe say 25, and this I say maybe 15, and this I'll say maybe 10, and let's see how this function works for me. So I'll say solve. I'll say, remember what I've done is whatever this value, this will be, we have to type the value in these cell boxes, and this value, whatever the value come here, it will automatically come here. So this will be the final result. Let's say solve. You can see that each of this has been, it's 100%. And my graph, this illustration is that this is my maximum limit, this is my minimum limit, this is the blend required. This is the blend required, and this is here. So if you know how to draw this Excel graph, and you can see my required blend is right in the center. There are some limits that is being violated, say for say number 38C, 3 by 8, and say but it's it's within those beds. So as far as these are the beds, it's low. So in order to have this blend, I can safely say that I have to add 29% from bin 1, 44% from bin 2, 21%, and from bin 3, and 6% from this. Now, in this Excel sheet, this will, what I've done, I've linked these values here. So in order to have 1 ton of mix, this is the weight that will be required. Obviously, weight of asphalt required, the percentage, it's determined from Marshall mix design method or super pave mix design method. So once you know, so you can always hand over this material, this sheet to the plant operator, that this is how he's going to operate and prepare a mix for us. So by just using Excel, the life has become very easier to proportion the aggregates. I hope that my videos is good enough, and it will be, and if you want the the Excel file for yourself or for your organization, just fill up the Google form that will be available in the description, and that this Excel file will be communicated to you with on your email address. So there is no cost for it. My videos, they are just for the purpose of education. Thank you very much, and I hope my next video will be of on the topic. Obviously, the circle of my topic is around transportation engineering. Bye and take care.